an hour. Let's go. Sequences and series. So sequence of events. First, second, third, right? What happens first? What happens second? What happens third? Etc. What do you guys see about the notation of what I have written down here? Not that you've never seen it before, but let's remind ourselves. First. What would indicate the first in the sequence below? A1. So what do you think the subscript is standing for? First. So then A sub 2, the subscript is standing for second. A sub 3 standing for third, etc., etc., etc. To where I can label this guy, interestingly enough, what would we call him? And term. Does that make sense? If a term is a certain number that's in a certain spot of a sequence, or as we'll see, a series, A sub n is just talking about the n. Wherever one is in the n spot, those of you guys are distracted. Focus down, let's go. So first, second, third, and then all the way up to n. Why is it called n and not nerd or nst? Why is it called n? Anybody know? Or n. Fourth, fifth, sixth, seventh, eighth, ninth. Which one is used the most? Yeah, th, right? So anyway, and plus nerd would just be kind of funny. Anyway, so coming back. Third nerd. And then N and D, that doesn't work at all. And then N just sounds like you have some sort of something going on. So anyway, coming back. Nth term, right? If you guys notice down below, A sub n, if I have some sort of A sub n equals, this is what we call the nth term formula. Because the nth term is equal to, what does it equal? Well, whatever follows that, if it's not a number, then it's some sort of nth term formula. So just a little bit of vocab. Domain for all sequences, for all series, is integers. Now, careful, careful, careful. Not just integers, positive integers. Question, would it make sense to have an n, a subscript, be a decimal? Does that make sense? Could I have a sub n where n is 1.5? Or could I have a sub n where n is 2.7? Does that or does that not make sense? Why doesn't it really, and really not at all? What do you mean?
You can always have another one at the end and shift it.
Well, that just says that it gets bigger forever. But what about like decimals or fractions? Why does it or doesn't it make sense that we have n's, aka domain? Domain is a set of all n values. You won't run out. That's true. But that would be the same whether it's counting numbers or whether it's including fractions or decimals, right? You wouldn't run out either way. Maybe you have the idea, you're just not verbalizing it fully. Does anybody have a reason as to why fractions and decimals wouldn't make it end? It would actually include more values. It wouldn't be just the 1, the 2, the 3, the 4. It'd be the 1 and the 1.5 and the 1.1 and the 1.9 and the 1.75. All the way, all of those before the second. Why would fractions or decimals not make sense, or make sense for n values? Huh?
I'm just thinking if they're events, then they can't be like, you can't say half of an event.
Exactly. It's either the first, or it's the second, or it's the third. Can you have the first and a half event? Does that make sense? What's first is first, what's second is second, what's third is third. Like, where would 1.5 go? Like, up in space somewhere? Like, no. So yeah, just think about sequences, sequence of events, sequences of terms. We're making it mathematical. So the notation for these, what do I mean by integers? Remember, integers are all the positive and negative counting numbers, but why is it saying only positive? Yeah, how do you have the negative first, right? But I'm talking about what happened first and what happens before that, right? In the beginning, that was first. Ooh, now we're going all biblical. But in the beginning, that was first. What was before first? Well, God was, but nothing was happening. At least not in our timeline. So anyway, fractions, decimals don't make sense. Positive numbers only make sense. But hold on, why would you ever start at 0 instead of starting at 1? Why would you ever start at 0? Instead of just always starting at 1. Any ideas? That could be like the very, very, very beginning, whereas 1 could be after 1 hour has passed, or after 1 second has passed, or after 1 meter has been gone. All of you guys with headphones and with phones, I'm wondering what you're doing, and I'm kind of skeptical, actually very skeptical. So coming back, n equals 0, n equals 1. 0 could be truly at the beginning. Not so much like the first as in the first thing that happened, but at the beginning, initially. And now we start talking about physics because 0 could be something like the beginning of time. Time equals 0 for some situation. Okay, moving on. Bloop, there we go. The first 4 terms of the sequence. Well, if n is like domain, then n is like my x value or my plugging in value. So if it says the first term, second term, third term, if it says a sub 1, a sub 2, a sub 3, a sub 4, and if I have a formula for all the terms encapsulated into the nth term formula, guys, it's so easy in that. How do I find the first term? How is it so easy? What is the only thing that you really have to do to find it? Nope.
Oh wait, find out what happened first.
Yep, and how?
Or n.
N? What about n? Yeah, if you just, you got it. If you just what?
You just
Do the what?
formula.
Exactly. If I just do the formula, aka, what is this known in math when all you gotta do is plug in? It's a plug in. Plug and chug. Let's go. Because you're gonna plug in what happens first, what happens second, what happens third, what happens fourth. Now, we don't have a story. We're not doing like a timeline. We're literally just saying, so we just know what's going on by when n is 1, when n is 2, when n is 3, when n is 4. We just plug and chug. So therefore, what is the first term, cool kids? Yep, it's just 1. What's the second term? What's the third term? What's the fourth term? What? Oh, 10. I don't know why I thought you said n. I'm so sorry. Question, is there a pattern? Oh, you party pooper. Is there a pattern?
Patterns aren't the best. This is how you get good equation.
There is a pattern in the equation, but for most people it's hardest to see in the equation, and it's a lot easier to see when you actually plug things in. What's the pattern between what happens between the first and the second and the third and the fourth? Plus what? Yeah, every single time the pattern is you're adding 3, but can anyone look in the formula and say, oh, of course you're adding 3 every time. I see it in the formula. Why is that causing addition? And what is multiplication defined to be? Repeated addition. 3 times 2 is 3 plus 3. 3 times 3 is 3 plus 3 plus 3. 3 times 4 is 3 plus 3 plus 3 plus 3. Multiplication is repeated addition. So if my multiplication is growing every time, then my addition is growing as well. But that's hard. You see a multiplication, you don't think addition, but sometimes plugging in numbers, you're like, oh, I see it. This is a special example of something we're going to talk about soon called an arithmetic sequence. Some people call it arithmetic. All right, that's no fun. An arithmetic sequence. An arithmetic always adds by a constant. No, go for it.
Sorry, can I use it?
Oh, party poopers. Go fast. Don't get lost. And leave your phone behind. Who's still writing? 5, 4, 3, 2. Who's still writing? Okay. Defining sequences. You guys are obviously bored, so I'm going fast. Defining sequences. Everything's fine. He's got so worried. Are you writing? Are you writing? Are you writing? Defining sequences. So we just talked about a formula for an nth term, a sub n. So sometimes they give you the formula and they say, hey, a sub n is equal to, I don't know, some sort of formula. We could call it like an f of n, a function in terms of n, okay? If we were talking about it in old school, like algebraic language, we would be calling it a function of n. But we don't really call it that in sequences. We have it look like this instead, so that the subscript is telling us like which term it is, kind of. But they mean the same thing. If they give us a formula, it's like, cool, plug in 1, plug in 2, plug in 3, we can get our sequence of numbers. But at other times, they give us the sequence. Usually starting at 1 for like the introductory treatment of sequences in series, but it could start at 0. Kind of like we talked about, 0 would be at the very beginning, time hasn't passed yet. There's a reason why some people would use a sub 0 as their beginning. So back here, guys, we had a formula given, and so we went from the formula to the sequence, so we could technically keep going. 1, 4, 7, 10, etc., etc., etc. We could go however far you want us to go. Might be tedious, but we could get there if we just keep going. But over here, what if they, do you see the example? What if they give us the sequence instead? A sub n. Subscript n, yeah. It's a little tiny n. This one, they're saying, we're giving you the sequence, you find us the formula. Now, this is where things get tricky. And even if you find a pattern, the question is, can you actually mathematically express the pattern as a function of n to fill in our formula for a sub n, subscript n? Who sees a pattern? Oh, so many people. Joey, go.
Oh, that was me.
Oh, Brendan, go.
N squared minus 1.
Ah, you party pooper, you went straight to it. But good job.
Wait, what?
Does anybody see any other pattern? Does anybody see any other patterns? Andy?
It's adding by 2, like, you're, like, it's like 3 then 5, then 7, then 5.
Okay, no. In his head,
I don't know, like,
in his head, the first addition is what?
it's 3.
And then the next number is 2 higher, 5, and 2 higher, and 7, and 2 higher is 9.
Yeah, that's right.
But the rest of us would probably say something like, oh, it's adding increasing odd numbers, right? You add 3 and then 5 and then 7 and then 9 and then 11. It's like, oh, it's adding an odd number every time. And you're right, and there is a way to talk about that pattern, but we just don't know it yet. Maybe if you see that pattern, you're meant to be a computer programmer, because there's something called recursive programming or recursively thinking or defining something. Recursive is like a step after step after step sort of process. Recursive could say we're adding odds. The problem is the adding odd thing would be a whole lot easier if we use this notation called like a sub k. Usually with recursive we use k kind of as an in-between. We could say a sub k is equal to a sub k minus 1 plus 2k. I don't want the parenthesis there, I apologize. Plus 2k plus 1. We could do something like that. Where a sub 1 is equal to 0. Now this looks really weird, and we're going to talk about it in a future slide. If it's not today, then we'll talk about it on Monday. But coming back real quick, if you start at 0, oh hey, that's telling me where to start. Ding, 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 ding. And then it says, how do I get to the next one? Well, to get to the, this is from Algebra 1, if your teacher taught it to you back in Algebra 1. To get to the next term, let's do it this way. To get to a current term, for instance, in this formula, I have the first, I need the second, but to get to the second, I need to look at the previous term, adding in whatever k I have. So hold on, what did I just say? I have the first, I need the second. To find the second, I need to look at the one before, which is the first, and add, what's 2 times 2 plus 1? I should have done minus 1. Hold on, I made the wrong formula. Sorry. That would have been 5. Get to the second term, I have to use the first term, 0, plus the second term puts it at 2. 2 times 2 is 4. What's 4 minus 1? 3. To get to the second, don't worry, we'll talk about it in a future slide, but to get to the second term, k is 2. I think about the previous term, a sub 1, which is 0. Plus, I'm looking at the second term, so k is 2. 2 times 2 is 4, and 4 minus 1 is 3. Adding 3, I get 3. To get to the third term, I would use the second term, which was 3, and I would add 2 times 3 is 6, and 6 minus 1 is 5. You can always get odd numbers by saying, hey, let's think about all the evens, all the 2 times, and let's either add or subtract 1, because then every time, if you're 1 away from an even, you're adding odd. Anyway, these are all tricks, but Brendan said something else, and I was like, oh, party pooper. Usually people see the plus 3, plus 5, plus 7, etc., but that doesn't actually help me for what we would call an explicitly defined formula. Explicit says you don't have to jumpity jump to get there. Instead, you just get to plug straight in and go straight there. So check it, explicitly defined. Going straight there, not jumping every time by adding like another 3 and then a 5 and then a 7 and then a 9. How do we get to the 10th term? I don't know. Do the 3 and the 5 and the 7 and the 9 and just keep on going until you're at the 10. This way it says, nah, I know what the 10th term is. The 10th term is 99. And why is it 99? Because this formula says, use your n squared and take away 1. What? What's right above 0? 1. What's right above 3? 4. What's right above 8? 9. What's right above 15? 16. What's right above 24? 25. All of these are just one quick subtraction away from a perfect square. Snazzy. Are there different ways of looking at sequences? Yes. Which one is easiest to get to the 100th? Oh, I said 10th, sorry. We could also say the 100th, but to get to the 10th, this one's easy. 10 squared is 100. 100 taken away 1 is 99. What would you have to do to get to the 10th term over here? Well, I don't know. I'm at the 1st, I'm at the 2nd, I'm at the 3rd, I'm at the 4th, I'm at the 5th. Let's keep on going. Let's go to the 6th, and then the 7th, and then the 8th, and then the 9th, and then the woohoo! Then we'll be at the 10th. This might be easier to see, but it takes more work and it takes longer for the human mind to do. Whereas explicit is much easier for the human mind, but for a computer it goes fast. We could just tell it what to do and it'll spit it out. If you learn how to code. Okay, moving on. Boop. Let's talk about that K dude. Let's talk about that jumpity jump jump. Let's talk about that. Let's make a computer do it for us and have us think less. Or maybe think simpler. Recursive sequences. Always defined in terms of previous terms. Describes how to progress. I say jumpity jump jump, but that's fine. Progress from one term to another. Pros, usually you can use a simpler pattern. Usually there's a simpler pattern involved. It might take some work to figure out the math behind it. Cons is to get to a term, you need all the previous terms. To get to the 10th term, you needed the first 9 terms, and then you were able to make the jump to the 10th. To get to a 100th term, you would need the first 99 terms to get to that, to make that jump to the 100th. And if you guys are wondering what's going on down here, there is no previous term yet. It's because my little notation wasn't allowing me, my little equation editor was kind of limited in the program I was using to where it wouldn't let me do more than one thing. There's supposed to be a K-1 down there. And why do I put Fibonacci here? Because Fibonacci is very much of a jumpity jump 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 type of formula, at least as far as the simpler pattern that everybody always uses. 1 plus 1 is 2, 1 plus 2 is 3.
Ryan says that he said already to the, I think he's gonna try to join us.
Oh. I think my sound's on to where I should be able to hear him. Well, he might want to do a note check and stuff because he wanted to show me some stuff over the Zoom camera. So we could do that. Thanks, Noah. Should be able to hear if he clocks in. So then, guys, we talked about if it was an A sub n, we would plug in n is 1, n is 2, n is 3 to get our first few terms and do a dot, dot, dot. But recursively, how do I start making this sequence? What's my first term, cool kids? Oh, it's nice. It's easy. They tell me my first term. But how do I get to my next term? -2 times 14. Ryan is noticing that this lingo up here, he's noticing, hey Ryan, this lingo up here, this says, hey, I'm the first term, and guess what? Use the previous term. Do the pattern, whatever the pattern is. Perform the pattern to get to whatever term you actually need. So, Ryan Union, one more time. We knew that 14 was the starting point, and then what's the next term going to be one more time? -2 times 14. So this would be a -2 times 14. I mean, I know some of you guys do that mental math. I want to prove a point. How would I get to the next term? Times -2 again, right? How would I get to the next term? Times -2 again. What do you see is going to start happening? What am I accumulating every time? another negative 2.
Power. And this way.
And how do I show repeated multiplication? I can show negative 2 squared times 14, right? Or negative 2 cubed times 14. Now, once again, I mean, you could say that's negative 28, you could say that's going to be positive 56, you could say that's going to be negative 112, etc., etc., etc. But what I'm trying to show you is some of the pattern aspect of it. This would be negative 2 to the 1. Question, what's negative 2 way back here? He's not there. Or is he? What could be the power of negative 2? Look at the pattern. Because anything to the 0 power is. So then couldn't I technically, now check it, this is a recursive formula, right? This was recursively defined. I did my jumpity jump, jump, jump. But question, could it make sense that my nth term formula would be negative 2 to the n minus 1 all times 14? Wait, what? Because if I start at a sub 1, I need the negative 2, 1 minus 1 to not be there. So starting at a sub 1, my negative 2 is gone, but a sub 2, 2 minus 1, I do have a negative 2. A sub 3, my third term, 3 minus 1, is negative 2 squared. Sometimes working with it recursively can show us how to get to it explicitly. But anyway, that's just a little bit of lingo. Ryan, as you're in here, oh, sorry, they see your black screen. Hold on, give me a second so they can see me and not you. Got it. What we did to start off class is actually, after the quiz, they could have scanned the QR code. I just pulled up the link, but they watched this video on the Fibonacci sequence just kind of as a detoxing from the quiz. Then we went ahead and just started taking notes on things to do with sequences and series, and we're up to here right now. We won't finish the whole thing. So homework will probably be due for this section next Wednesday. I think it's chapel. No, next Tuesday, because it's chapel, then AB, so next Tuesday. We're not totally done yet, even though they're trying to totally pretend to be done. We have one more page. We've already talked about oh my goodness. Yeah, babies. It has to do with factorial, and we've already been there. We've already done that. So let's just see what's new, what's different, and how or where we're leveling up. And then, Ryan, if you have any notes or spirals to check, we can do that as soon as class is over, okay? As you guys look at the screen, factorial. You already know it, but the weird thing is, guys, when you thought about a factorial, like 8 factorial, when you thought about a factorial, like 8 factorial, did you think of 1, 2, 3, 4, 5, 6, 7, 8 all multiplied, or 8, 7, 6, 5, 4, 3? I know, but that's dangerous. Because as soon as you don't have a number and you have a letter instead, it gets very dangerous if you think of it as working from the top down instead of the bottom up. I'll show you why in just a second. You can't see. What can't you see? I mean, I don't really know if that helps. Anyway. N factorial. Thank you. N factorial is 1, 2, 3, 4, and you count up until n, and what is right before n is n take away 1. What's before that? N take away 2, and what's before that? N take away 3. 0 factorial, I mean, this one's a little bit interesting. I'd have to show you some different properties as to why this is true. For instance, if I was to do something like 8 factorial all over 7 factorial, what would that end up being? It'd be 8, 7, 6, 5, 4, 3, 2, 1, I know, and then 7, 6, 5, 4, 3, 2, 1, I know. It ends up being 8, right? I could do something also like 6 factorial all over 6 factorial. What does that end up looking like? Everything goes away and I end up getting 1, right? I could do something like 4 factorial all over 2 factorial. That would be like a 4 times a 3, right? And that equals, 1. If we were to try to find some sort of pattern with what's going on, couldn't I say that this is, oh, how could I do that? I had it and then I lost it. I'm showing you the wrong thing, and that's not the thing that I need to show you. Let me recap and review. Why do I always lose this one? There's a way to show it, but I was not doing it well. Let me put a big old red star so I can remember to come back. I know some of you guys are wondering why, and I have a proof as to why, but I was going the wrong direction and I can't backtrack in my head fast enough. But let me show you instead a couple things to do with factorial. First of all, there is a big difference between 2n factorial and the quantity 2n factorial. In PEMDAS, there are no parentheses around this guy, so it would be 2 times what? 2 times n factorial. So in PEMDAS, factorial comes before multiplication. Factorial would be kind of in the exponents category. As in parentheses, sure, exponent, sure, or they even kind of showed it with parentheses. But factorial happens before multiplication. Multiplication is a lower priority operation, like addition and subtraction. Sure. Yes. You can do your factorial times 2, which is very different than doing your factorial all the way up to 2n. So something like I would have, let's see, 2 times 10 factorial is way smaller than 2 times 10 factorial, if I was to put a number in it. Because 2 times 10 factorial says 1 through 10 doubled. The other one says 20 factorial. It's quite a bit larger. Let's leave it at that. But then let's go ahead and say, okay, so what if we have some sort of nth term formula where factorials come into play? And if I was starting at 0, then I would be finding the first 5 terms, which would go until, guys, what would be my highest subscript if I'm doing the first 5 terms? Because 0 counts as a number if I'm starting at 0, so I wouldn't go to a sub 5, I would go to a sub 4, and my whole reference system has changed to where 0 is the first, 1 is the second, 2 is the third, etc. But I would just be doing what I did before, plugging and chugging as far as 2 to the all over that factorial, 2 to the all over that factorial, 2 to the all over that factorial, etc., etc., etc. Plugging in 0 first, plugging in 1 next, plugging in 2 next, etc., etc. And this is where you would need to maybe know that fact, that 0 factorial is 1. So what is 2 times 0? And what is 0 factorial? So 0 over 1, can I do that? The answer is of course. And 0 times 1 equals 0. 1 times 1 equals 0, 0. No big dealio. How about this one? I would have 2 over, what is 1 factorial? Just, well, that's weird. 0 factorial is 1 and 1 factorial is 1. Yes, it is. And once again, I know. I need to still show that to you next class. How about this guy? 2 factorial, sorry, 2 times 2 is 4. What's 2 factorial? 2 times 1? 2. 4 divided by 2 is? This is an awkward sequence. I mean, it's staying the same, and sometimes it's changing. If I was to go one more, I would have 2 times 3, right, which would be 6. And then I would have over 3 factorial. What's 3 times 2 times 1? Anybody with me?
6.
Interesting. So this would be 6 over 6? So does every sequence always, like, continually get bigger or continually get smaller or continually change by a pattern? No. There's some funky sequences out there. This guy that I showed you with an n factorial is probably from Calc BC. That's where you would start seeing kind of weird things like this. But this would be a possible sequence. Just letting you know they don't all follow your expectations of what a sequence is. I had a question from Baron and then a question from Andy. Baron, go first. Oh, I was not raising powers. I was multiplying. Lame sauce. I'm sorry, guys. Did you guys catch that? And I did not. I was multiplying. Oh, you know what? I got you. Here's what will change. You ready? Bummer. That's not what I was trying to show, but that's okay. What do I need to do to make this work? What did I have us plug into? 2 times n over n factorial. At the very beginning, it went up, and now it seems to be going down. I wonder what's stronger, linear growth or factorial growth? We'll get to that next time, and we're going to start with, how do we do this if it has factorial? Tuesday. See you on